So very good morning students. In today's class we are going to solve problems on IAR filter structure in the form of direct form 1 and direct form 2 structures. So the first problem statement is determine the direct form 1 and direct form 2 realization for the given difference equation y of n is equal to minus zero point 0.1 y of n minus 1 plus 0.72 y of n minus 2 plus 0.7 x of n minus 0.25 x of n minus 2. So as already I have told you the procedure how to draw the direct form 1 structure is. So whatever the given difference equation, let us write down again and take the Z transform on for the entire equation. Then we will arrange it in the form of y of z divided by x of z, so that you will be getting the entire transfer function. So here as I told, take Z transform of the above equation. So Z transform of y of n will be y of z, and Z transform of minus 0.1, it is a constant, let us write as such, and the Z transform of y of n minus 1 is z inverse into y of z, and Z transform of 0.72, it is again the same constant, and Z transform of y of n minus 2 is z power of minus 2 into y of z, and Z transform of 0.7 x of n is 0.7 x of z, and the Z transform of minus 0.25 x of n minus 2 is minus 0.25 z power of minus 2 into x of z. So once you take the Z transform of the above equation, so you can rearrange such that y of z terms will be on the left hand side and x of z terms will be on the right hand side. Then take y of z as common, so that you will be getting the next equation as y of z of 1 plus 0.1 z inverse minus 0.72 z power of minus 2, which is equal to x of z of 0.7 minus 0.25 z power of minus 2. So then rearrange such that it is expressing it can be represented in terms of transfer function h of z as y of z divided by x of z. So which is equal to 0.7 minus 0.25 z power of minus 2 divided by 1 plus 0.1 z inverse minus 0.72 z power of minus 2. So as already we have the difference equation from the given problem statement, that is this equation can be used in order to draw the direct form 1 structure directly, whereas this transfer function you can use it in order to implement the direct form 2 realization. So with respect to this given equation, you need to concentrate on x of n and its delay terms. So start with x of n, multiply with 0.7, then make a delay of x of n, you will be getting x of n minus 1. Again give it to another delay block to generate x of n minus 2. Then you can multiply with the corresponding coefficient as minus 0.25. So let us do this first. See, whatever you have x of n is your input and output is named as y of n. So directly you can multiply x of n with 0.7. It is given to the summation block. So as I told, you have to give this input x of n for the two delay blocks to generate x of n minus 2. So you should not combine these two delay blocks, and you can't write it as z power of minus 2. You have to take individual delays here. This you need to concentrate much. So take delay of x of n, the output will be x of n minus 1. Again take one more delay, so the output will be x of n minus 2. Then multiply with minus 0.25 and then give it to the summation block, so that you can add further. And similarly for the y of n, you concentrate on the y of n terms and its delay. So as per the given problem statement, we have to generate y of n minus 1, then you have to multiply with minus 0.1, and then generate y of n minus 2, multiply with 0.72, and if you add all these terms, you should get the output y of n. So for taking the delay of y of n, from y of n, give it to the delay block, the output will be y of n minus 1. Then you multiply with the corresponding coefficient minus 0.1 and give it to the summation block. Again take one more delay, so the output will be y of n minus 2. Then multiply with this coefficient 0.72 and give it to the summation block, and again this output is given to the another summation block, so that it can add the input and its delay, and finally you will be getting the output at this output point. So this represents the direct form 1 realization of the digital IAR filter. So next, in order to realize the direct form 2 structure, so we'll start with that is we are going to segregate the entire h of z as h1 of z into h2 of z. As already discussed, v of z can be written as x of z into h1 of z. That is nothing but the first transfer function h1 of z is equal to v of z divided by x of z. That is, it will be representing the polynomial which is related to the poles of the transfer function. So equate to this and then just cross multiply and take inverse Z transform. So we will be getting an equation v of n is equal to minus 0.1 v of n minus 1 plus 0.72 v of n minus 2 plus x of n. And similarly the other transfer function h2 of z, which is equal to y of z divided by v of z, where v of z will be the intermediate z transform of the intermediate output v of n. So v of z represents the z transform of v of n, where v of n is the intermediate output. So substitute h2 of z, then just cross multiply and take inverse z transform, and finally write what is y of n alone. So y of n we are getting as 0.7 v of n minus 0.25 v of n minus 2. So based on these two equations, that is v of n equation and y of n equation, we are going to draw the direct form 2 structure of the given digital IAR filter. So it is drawn such that first start with the input x of n and output y of n, and name the intermediate output as v of n. And in both the equations you can find commonly there are two delays. So start with v of n, take a delay, so the output will be v of n minus 1. Again one more delay you take, it is v of n minus 2. Then you just multiply with the corresponding coefficients as minus 0.1 and 0.72 respectively, and give it to the summation block. Again one more summation block, then finally it is flowing in this direction. And here another input from v of n minus 2 multiplied with minus 0.2. Again this is given as an input for this summation block, and the output will be available at y of n. So this represents the direct form 2 realization for the given digital IAR filter. So in the same way you need to solve for all the problems. So let us solve another problem which is given as obtain the direct form 1 and direct form 2 realization of the third order IAR transfer function, which is given as h of z is equal to 0.28 z square plus 0.319 z plus 0.04 divided by 0.5 z cube plus 0.3 z square plus 0.17 z minus 0.2. So how to start with this? Any transfer function if you are planning to draw direct form 1 realization and direct form 2 realization, you have to see that the entire h of z, it has to be in negative powers of z. So for that just convert this positive powers of z into negative powers of z. For that you can multiply with z cube and divide by z cube. So this will be your final transfer function, which has to be in negative powers of z. And for the direct form 1 realization, as already discussed, you just cross multiply it and take inverse z transform and write only what is y of z alone. Okay, so this particular equation, you take the inverse z transform, you will be getting the output equation as y of z equal to this entire equation. So using this equation, you can draw the direct form 1 realization. As already discussed, for the direct form 1 realization, first concentrate on the input and its delay and the corresponding coefficient, then the output, the delay, and the multiply with the corresponding coefficients to get the direct form 1 realization. See, as I told, you start with the input x of n and output y of n. From x of n, you take the delays and multiply with the corresponding coefficients and give it to the two input summation block. Again this is given to the final summation block, so that you can add the x of n as well as the delays from the y of n. See, from y of n, take a delay, multiply with the corresponding coefficient. Again another delay, multiply with the corresponding coefficient as minus 0.34. Again y of n minus 3 multiply with 0.4. Again you give it to the summation block, so that you will be able to generate the output y of n. So this particular structure represents the direct form 1 realization of your digital IAR filter. And similarly for the direct form 2 structure, as I told, you have to decompose the entire h of z into h1 and h2, whereas h1 of z, please always remember, it stands for the poles. So 1 divided by the denominator polynomial you have to write, and for the h2 of z, it stands for zeros, that is the numerator polynomial. Then just cross multiply and take inverse z transform and represent what is v of n and y of n. So this is what that v of n equation. So the another equation is y of n equation. So this equation which is written in bold. So based on these two equations, we are going to draw the direct form 2 realization. See, this is the direct form 2 realization. As I told, you need to start with the x of n first and y of n, and intermediate output is your v of n. Then based on those two equations, identify how many delay blocks are needed. Based on that, you just draw it and multiply with the corresponding coefficient on both the side. Then you generate the final output y of n. Okay, this is how you need to solve all the problems, provided either the input can be given in the form of transfer function or difference equation which represents your digital IR filter. You have to follow this procedure for drawing the direct form 1 and 2 realization. Okay, thank you. Thanks for watching. Let us continue in the next video. Thank you.